This thing screen. Okay. Uh, Hello. Today we will discuss about the next topic, that is wave optics. Okay. What is wave? Wave is simply an oscillatory disturbance traveling through a medium. Okay. And optics is the branch of physics which deals with three types of sections, that is geometrical optics, wave optics, and quantum optics. Put the chart here. Okay. So today we will discuss about wave optics. What is the difference between ray optics and wave optics? Ray optics discusses with lens systems and rectilinear propagation of light, whereas wave optics discusses the different phenomena considering the light as a waveform. Hmm? It discusses with different phenomena such as reflection, refraction, diffraction, polarization, interference, etc. Okay, so basic concept is that light is a form of energy and light has wave nature. That is the best to understood the different physical phenomena such as reflection, refraction, interference, diffraction, etc. Okay, so let us see one by one. What is wavefront? Wavefront is a surface drawn at any instant in the medium affected by the waves originated from a source on which each particle vibrates in same phase is called wavefront. This is wavefront. This is what the locus of all the points where all these waves are reaching should be in phase, at any instant of time. Okay, so that is called wavefront, the locus of all the points where we can get the same phase of all the waves. The wavefront may also be defined as hypothetical surface on which the light waves are in same phase. Okay, line perpendicular to the wavefront is called wave normal. It represents the direction of moving wave. So this is corresponds to spherical wavefront and this corresponds to plane wavefront. There are three types of wavefront: cylindrical wavefront, spherical wavefront, and plane wavefront. Already you have studied what's the difference in between them. The next one, Huygens principle. In 1678, in order to explain the propagation of a wave in medium, Huygens propounded a principle known as Huygens principle of secondary wavelets. So, as per Huygens principle, every point on a given surface or every point on a given wavefront can be regarded as fresh source of new disturbance and sends out its own spherical wavelets called as secondary wavelets. What it means? It means that suppose this wavefront and every wave reaching at this point, at this point, at this point, at any point on this surface will act as a source of secondary waves. Okay, next. So we are most acquainted with reflection, refraction, interference, diffraction. Okay, in order to have the reflection, ray of light has to incident on a denser medium. Okay, and the light is going to be reflected and the remaining part is going to be refracted. That means when the ray of light is going to be incident on surface separating two media, then part of the light is going to reflected and part of the light has to refract. That reflection will be considered if angle of incidence equals to angle of reflection. Okay, and incident light and reflected light should be in the same plane. These are the two conditions to explain the concept of reflection. Next one, refraction. When the ray of light is going to be incident on the boundary separating two atoms, then part of the light is to be reflected and remaining part is going to be refracted. Okay? And obviously, angle of refraction is smaller as compared to angle of incidence, because when the ray of light is going to enter from rarer media into denser media, it bends towards the normal. It bends towards the normal. Okay. And we have Smith's law as sine I upon sine R equals to mu. Mu is refractive index of the medium through which the light waves are traveling. Okay. So as per Smith's law, sine I upon sine R equals to refractive index of denser medium. Okay, now let us see for interference. Interference, in short, can be explained as light plus light is either maxima of intensity or minima of intensity. Light plus light is either maxima of intensity or minima of intensity, following the principle of superposition theorem. Okay. So, as per the definition, when two light waves superimpose, then the resultant amplitude in the region of superposition is different than amplitude of the individual waves. This modification in the distribution of intensity in the region of superposition is called interference. Okay, that means when two light waves are superimposing on each other to produce maxima of intensity or minima of intensity depends on the phase difference. Okay, so that phenomenon is called interference. So, which are the conditions to obtain steady interference pattern? All this part you have studied. The important condition that the two sources which are said to superimpose on each other to produce maximum of intensity or minimum of intensity must be coherent sources. Coherent sources means the two waves which are propagating through the medium must have the constant phase difference or zero phase difference. Okay, so two sources must be coherent. Next, sources must be close to each other. They should be very close to each other. Then sources should be narrow. Then sources should be monochromatic. Monochromatic. Chromatic, that is color. Mono, single. Single color means single wavelength. Two sources should be monochromatic. Then amplitudes of interfering waves must be equal. Means intensity of both the waves which are supposed to superimpose on each other to produce maxima and minimum of intensity must have same value. Okay, so these are certain conditions in order to observe the interference phenomena. Next, as per principle of superposition, as per principle of superposition of waves, displacement of individual wave. Let us suppose y1 is the displacement of first wave, y2 is the displacement of second wave, then y equals to y1 plus y2. That means resultant amplitude at the point of superposition must be equals to displacement of individual wave. y equals to y1 plus y2 plus y3 plus y4 and so on. By the principle of superposition, the resultant displacements y equals to y1 plus y2 equals to a1 sine omega t plus a2 sine omega t plus phi. Phi is the phase difference. From this expression, the resultant amplitude is given by a square equals to, okay, a1 square plus a2 square plus 2 a1 2 cos phi. Phi is the phase difference in between two superimposing waves. The resultant intensity I is given by I is directly proportional to A square. What is A? Is the amplitude of individual wave. Y resultant displacement. What is amplitude? Amplitude is simply the maximum displacement from its mean position. Maximum displacement of a particle from its mean position, that is a, y is displacement of a particle. Okay? Then we know that intensity is nothing but square of the amplitude. So I is directly proportional to a square. Also, I1 is directly proportional to a1 square. I2 is directly proportional to a2 square. Then intensity, resultant intensity at the location of superposition given by I equals to I1 plus I2 plus 2 square root of I1 I2 cos phi. If I1 equals to I2 equals to I0, the same expression we can write in terms of phi. This equation you have to remember, as based on this, one of the example was asked for one of the CET examination. Okay, I equals to 2 times I0, 1 plus cos phi equals to 4I0 cos square of phi by 2. Thus, resultant amplitude or the resultant intensity at a point depends on phase difference at that point between two superimposing waves. Okay, so ultimately, as per the principle of superposition of waves, hmm, if this is the point at which waves are supposed to interfere with each other, then y equals to y1 plus y2, that is resultant displacement, a equals to a1 square plus a2 square, resultant amplitude, and I equals to I1 plus I2, that is I equals to a1 square plus a2 square. Okay. Next, conditions for constructive interference. The two waves are supposed to interfere constructively in order to produce maxima of intensity. Okay, so constructive interference, maximum of intensity, and and bright band. ओके एक्झाम्पलमध्ये ह्यातला कुठलाही एक वर्ड वापरू शकतात पण दे मे आज टू कॅल्क्युलेट the example based on constructive interference, maximum of intensity, bright bands. Okay, meaning is one and the same. You should follow the condition of constructive interference, that is path difference equals to n lambda. What is the condition? Condition is simply path difference equals to n lambda. Hmm? Next, what it means? It means that two waves which are supposed to interfere. You see here, okay? When this wave is superimposing on another wave, then at this location you will get the maxima of intensity. Whereas at this point, if crest of one wave superimpose on crest of another wave, then we will get maximum of intensity. Trough of one wave interfere superimposed on crest of one wave, we will get condition for destructive interference. Crest of one wave falls on crest of another wave. Trough of one wave overlaps with crest of another wave. So ultimately, we can get here maxima of intensity and minima of intensity. Then next, condition for destructive interference. Again, three words are common: destructive, destructive interference, then minima of intensity, minimum of intensity, and third word they may ask by saying dark band. Okay, dark band. Then what is the condition? Condition is simply if path difference equals to odd integral multiple 2n minus 1 into lambda by 2 or 2n plus 1 into lambda by 2. Hmm? Then this condition is called the condition for destructive interference. When to consider minus and when to consider plus. That depends on if your n starts from 0, then you should have this particular formula. And if your sorry, if n starts from 0, then you should take this as condition for destructive interference 2n plus 1 into lambda by 2. If you're substituting n equals to 0, then 2 into 0 into lambda by 2. That is the condition for first destructive interference. Here, if you are using this formula, then you should take n equals to 1. So, first minima will occur by taking n equals to 1. And after substitution here, 2 into 1 minus 1. That is simply 1 lambda by 2. So, ultimately, by substituting n equals to 0 in this condition and substituting n equals to 1 in this condition will provide you the value for first minima of intensity. Okay, you should remember because in some examples they have taken 2n minus 1 and in remaining examples they have considered 2n plus 1. Okay, don't have any misunderstanding. Just your n should start from these values. That you have to remember. So, what is principle of superposition waves that we have studied? Then after that, we have studied for condition for constructive interference, maximum of intensity, bright bands. What is the condition? Path difference equals to n lambda. Okay, and here what is the condition for destructive interference? That is simply path difference equals to n plus or minus half lambda, n plus or minus half lambda, or 2n minus 1 lambda by 2. Okay, so these conditions you have to remember while solving problems. Now, in order to obtain steady interference pattern, sources must be coherent. Okay, sources must be coherent. That is very important condition. So, how to produce the coherent wave sources? There are two methods by which these coherent sources can be obtained. The first condition, division of amplitude, and second condition, division of wavefront. Okay, Young's double slit experiment or Fresnel's biprism are the examples which are called uh, means where coherent sources have been obtained. Coherent sources have been obtained by division of wavefront. Okay, division of wavefront means wavefront have been divided. इथे हा ओरिजिनल सोर्स होता, त्यापासून ह्या हे वेव्हफ्रंट्स आले आणि या वेव्हफ्रंट्सना परत दोन पार्ट्समध्ये डिव्हाइड केलं गेलं. ओके, डिव्हिजन ऑफ वेव्हफ्रंट जस्ट लाईक हिअर. हिअर इज द लाईट सोर्स. ओके, फ्रॉम दॅट we obtain these are the surfaces, and this beam of light is allowed to pass through two slits, S1 and S2. When this wavefront reaches at this point, again the point on this particular location again act as the source of secondary wave. Okay, so again new wavefront have been generated at this point and at this point. Again, these two wavefronts, when they are propagating through the medium, there are certain regions where these wavefronts overlap with each other as per principle of superposition theorem. Okay, so when crest of one wave overlaps with crest of another wave, then we get maximum of intensity. In another sense, we said that when crest of one wave overlaps with the trough of another wave, we will get the condition for destructive interference. So, how the coherent source have been obtained? Single wavefront have been divided into two wavefronts, and these two wavefronts, when they are propagating through the medium, there is a possibility that they are superimposing on each other. Okay, so as per that reference with this Young's double slit experiment, we have obtained here path difference. What is important? Important condition is that path difference should be integral multiple of lambda. To consider, that is the condition for constructive interference. And if path difference is equal to n plus or minus half into lambda, then that is the condition for destructive interference. Okay, there are two methods that we said. That is first one division of wavefront and second one division of amplitude. Division of amplitude, the examples are interference in thin films, interference in wedge-shaped film, interference in Newton's rings, etc. Whereas division of wavefront method is utilized to observe hmm, the interference pattern in Young's double slit experiment, Fresnel's biprism, etc. Okay? So I'm showing diagram the path difference between two waves. What is the path difference? Here you can observe, here is the original source. From original source, you are getting this is the original wavefront, and when it reaches here, at this location, again, it will act as a source of secondary waves. Okay? Again, at this point, it will act as a source of secondary wavelets. Okay? So, this is the first ray, S1P, that is the first ray, reaching at point M to produce either maximum of intensity or minimum of intensity with the ray that have been coming from this S2P. So S1P is the first ray, S2P is the second ray. They are supposed to interfere at the point P to produce maximum of intensity or minimum of intensity. And if you are observing very carefully, then the distance traveled by first ray, distance traveled by S1P is not equals to distance traveled by S2P. Okay, both the distances are not same traveled by two rays which are supposed to interfere at P point. ओके, हे डिस्टन्स इथे कमी दिसतंय आणि हे डिस्टन्स हे जास्त दिसतंय. ठीक आहे, मग ह्या दोन डिस्टन्सेस मधला जो डिफरन्स असतो त्याला म्हणतात पाथ डिफरन्स. त्याला म्हणतात पाथ डिफरन्स. आणि तो आपल्याला कॅल्क्युलेट करायचा असतो आणि मग कंडिशन आपण अप्लाय करू शकतो. ठीक आहे. पाथ डिफरन्स मीन्स व्हॉट, whichever are the two waves supposed to interfere with each other, then distance traveled by first train and distance traveled by second train, difference in between them, that is called path difference. And if path difference as an integral multiple of lambda, then we can get the condition for constructive interference, which produces maximum of intensity. And again, it is said as it produces bright band intensity. Okay. So, as per the geometry, we have calculated this. You have studied this all for theory. You just go through it. So what is the path difference here? Path difference is S2P here, S2P minus S1P, dropping a perpendicular from S1 on from first ray onto second ray. ओके. ह्या ठिकाणी आपण इथे परपेंडिक्युलर टाकतो आणि तो परपेंडिक्युलर पासूनचं हे डिस्टन्स आणि इथून इथलं डिस्टन्स हे सेम असतं आणि मग ॲडिशनल डिस्टन्स असतं ते डिस्टन्स म्हणजे पाथ डिफरन्स असतो. ओके. अँड हाऊ इट इज टू बी given, it is given by dy upon d. What is d? D is the distance in between source to the screen. This d. D is what? Distance from source to the screen. Then which is large as compared to d. What is d? D is the separation between two slits. Okay, separation between two slits. Here is first slit S1, here is second slit S2. Difference, or sorry, distance in between S1 and S2. That is separation in between two slits. That is D, this distance. Okay? So D into Y. What is Y? Y is the displacement. म्हणजे इथे जर इंटरफिरन्स होतच नसेल, इथे डायरेक्टली रेझ्युम इन्सिडेंट होत आहे, तर in the presence of such wavefronts, if you are getting maximum of intensity or minimum of intensity on the screen, ठीक आहे, तर हा बीम ऑफ इलेक्ट्रॉन इतकं डिस्टन्स डिफ्लेक्ट झाला म्हणजे आता तुमचा बीम ऑफ लाईट सुपरपोजिशन थिअरमनुसार इथे येऊन सुपर इम्पोज होतोय. ठीक आहे. आणि ही जी डिस्प्लेसमेंट आहे इट इज नोटेड बाय वाय. व्हॉट इज वाय? वाय इज द रिझल्टंट डिस्प्लेसमेंट वेअर दे आर सपोज टू इंटरफिअर विथ इच अदर. व्हॉट इज डी? डी इज द सेपरेशन इन बिटवीन सोर्स टू द स्क्रीन. What is this small d? Small d is simply separation in between two slits. Remember, d, d and lambda and y. Y, or sometimes it can be denoted by x also. Sometimes it may be denoted by delta x. Okay. And one more parameter, beta. Beta is what? It's the fringe width. Fringe width is distance in between two successive bright or dark fringes. Distance in between two successive bright and dark fringes. It is given by beta. Beta is called fringe width. D, separation in between two slits. Capital T, distance in between source to the screen. Lambda, wavelength of the incident light. Y, resultant displacement of the beam of light. Okay. So there is formula you have to remember. Fringe width in case of Young's double slit experiment can be given as beta equals to d into lambda upon d. ठीक है. Then separation between two consecutive bright fringes. Separation between two successive bright fringes and two successive dark fringes. Okay. So this is the expression for separation between two successive or consecutive bright fringes. Now the separation between two consecutive dark fringes is given by beta equals to 2n minus 1 into d lambda upon 2d. Because here n is to be replaced by n ची व्हॅल्यू कशाला रिप्लेस केली पाहिजे इथे बघा this n has to be substituted by n plus half or you substituted it by 2n minus 1 into lambda by 2. ठीक है? So here lambda is common in all. ठीक है? Here also lambda. Uh, okay, so beta equals to n lambda. Beta equals to n lambda into d upon 2d. D upon d. D upon small d. It is the fringe width expression for fringe width. And here beta equals to 2n minus 1 d lambda upon 2d is the expression for separation between two consecutive dark fringes. Okay. Then this the intensity distribution curve. Okay. So figure shows the variation of intensity I on both sides of the screen of Young's double slit experiment. Okay. Next, here is the expression for fringe width. Fringe width beta equals to d lambda upon d. Just now we have said that fringe width is directly proportional to lambda or inversely proportional to separation in between two slits. Okay. Fringe width is directly proportional to lambda. Hence, the fringes of red light are broader than fringes of blue light. This thing also you should remember. जे लॅम्बडा शॉर्टर असेल तर त्याचा बीटा हा क्लोजली स्पेस्ड असतो म्हणजे सेपरेशन बिटवीन टू फ्रिंजेस विल बी स्मॉलर. लॅम्बडा स्मॉलर असेल तर बीटाची व्हॅल्यू पण स्मॉलर असते. लॅम्बडा जास्त असेल तर बीटाची व्हॅल्यू पण जास्त असते बिकॉज दे आर directly proportional to each other. By keeping in mind that for the same experimental setup, if you simply changing lambda, lambda फक्त तुम्ही चेंज केला म्हणजे काय कलर रेड कलर किंवा व्हायलेट कलर किंवा ग्रीन कलरची लाईट ही हा सोर्स फक्त तुम्ही चेंज केला लॅम्बडा चेंज होणार आणि त्या प्रपोर्शनेटमध्ये त्यांचं फ्रिंज विड्थ पण चेंज होणार. ओके. Next one, angular fringe width of interference pattern. It is given by theta equals to beta upon d. What is beta? Beta is the fringe width. Fringe width upon distance in between source to the screen. Distance in between source to the screen. It is given by lambda upon small d. ठीक है? So हे आपण कशावरून आलं तर जॉमेट्रीनुसार जर यंग्स डबल स्लिट एक्सपेरिमेंट इथे आपण बघितला तर हे जे आहे दिस ओके. सो दिस इज वाय दिस वन इज डी अँड दिस द सेपरेशन इन बिटवीन टू स्लिट्स. सो व्हॉट इज थीटा? थीटा इज इफ दिस थीटा equals to if theta is very small sin theta can be taken as equals to tan theta. So here as per geometry tan theta is equal to this y upon d. So as per the geometry itself we are getting theta equals to beta upon d. What is beta? Beta is the separation in between two fringes. Okay. Now if the whole apparatus of Young's double slit experiment is immersed in a transparent medium of refractive index mu. The fringe width in the medium is given by beta equals to d lambda upon refractive index of the material into separation into two plates. आता हे सगळे फॉर्म्युला तुम्हाला लक्षात ठेवायचे. Next one. So this is the case of how to obtain coherent sources by using bioprism experiment. The first method, which method? Division of wavefront. Original wavefront have been divided into two wavefronts, and these two wavefronts, when propagating through the medium, they are supposed to interfere with each other to produce maximum of intensity or minimum of intensity That phenomena is called the interference phenomena. Okay, now next. So this is all about interference. Now let us talk in short with diffraction. Okay? What is diffraction? In short, diffraction is a scattering phenomenon. Hmm? So when uh, as per the geometrical optics, light always travels in a straight line path. But if any obstacle is coming in its path, then light bends around the obstacle, or when it passes through very narrow aperture, then at the edges, light is going to be scattered. So, bending of light near the edges of an obstacle or slit and spreading into the region of geometrical shadow is known as diffraction of light. Diffraction is one type of spreading or one type of scattering which follows certain conditions. Okay? Which are those conditions that we will see? So bending of a light near the edges of an obstacle or slit and spreading into the region of geometrical shadow is known as diffraction of light. Okay? So there are two types of diffractions, President's class of diffraction and Fraunhofer's class of diffraction. You already studied all these parameters. President's diffraction, distance between source to the obstacle and obstacle to the screen is finite. Then spherical or cylindrical wavefront is used. No lens system is required to study Fresnel's diffraction. Okay, whereas as compared to Fresnel's diffraction, Fraunhofer's diffraction says that distance between source to the obstacle and obstacle to the screen should be infinite. Plane parallel wavefront is used. Lens system is required to study different purpose diffraction. Okay, this is all there for your syllabus. Next, what is the difference between so which are the three parameters which differentiate in between Fresnel's diffraction and Fraunhofer diffraction? Basically, no lens system is used in uh, Fresnel's diffraction. Fraunhofer diffraction uses the lens system. Fresnel's diffraction uses spherical or cylindrical wavefront, whereas Fraunhofer's diffraction observes with reference to plane parallel wavefront. And major theme, distance in between source to the obstacle and obstacle to the screen is finite, and distance between source to the obstacle and obstacle to the screen is infinite in case of Fraunhofer's diffraction. Now next one, differentiate between interference and diffraction. Interference is where light plus light is either maximum of intensity or minimum of intensity. Okay, so basically, in order to observe the interference phenomena, these are the points that should be followed. So coherent sources are required, monochromatic sources are required. Okay, uh, coherent sources are required, monochromatic sources are required. Whereas in case of diffraction, no such requirement is there. Coherent sources are not required. Monochromatic source uh, are also not required. Interference fringes may or may not be of same width. Diffraction fringes are certainly not of the same width. Points of minimum intensity are perfectly dark, whereas points of minimum intensity are not perfectly dark. Interference is simply the composite effects of light waves coming from two different wavefronts originating from the same source. So coherent sources are required. And diffraction pattern is the resultant of light waves coming from different parts of the same wavefront. Different parts of the same wavefront. Okay, so no requirement of coherent sources is there. So I shown a diagram. We can say this is the Fraunhofer's diffraction at single slit. Obviously, here is the source that is not shown here. Here is the source which emits this spherical wavefront, and that spherical wavefront is allowed to pass through such convex lens. Okay, then, when this wavefront is allowed to pass through such convex lens, then we can obtain the plane wavefront. The locus of all the points at which these waves are reaching is having same phase at any instant of time. Okay, so this plane wavefront is shown here directly. Okay, so this is the plane wavefront. That plane wavefront is allowed to pass through the single slit of certain width. ह्याची width ही आपण E इतकी suppose केली आहे. AB, length of AB equals to slit width E. ठीक है? So E is the slit width. And again, at this point, when this plane wavefront is reaching, then at the edges, instead of traveling this light in a straight line path, इथे जर तो इथे इन्सिडेंट झाला नसता, हा लाईट सिग्नल, ही लाईट वेव्ह इथे इन्सिडेंट झाली नसती, तर ती सरळ रेषेत पुढे गेली असती आणि या लेन्समधून जेव्हा पास झाली असती तेव्हा ती इथे फोकल झाली असती. पण इथे ह्या पॉइंटला जेव्हा ही वेव्ह रीच होते तेव्हा ती स्कॅटर्ड होते किंवा ते डिफ्रॅक्ट होते. Okay, at the same time, here is also the possibility of scattering this wave. And when this scattered wave and this scattered wave are propagating through the media, and after passing them from the convex lens, okay, we are supposed to meet at point P to produce maximum of intensity or minimum of intensity. ओके, इथे पण तसंच हा रे इकडे ट्रॅव्हल होईल, इथे येईल. ठीक आहे, हा रे इथे ट्रॅव्हल करेल, म्हणजे हे डिस्टन्स इथे पण पॉसिबिलिटी आहे. दिस इज पी डॅश अँड दिस इज पी. P is the point of minimum of intensity, and P dash is the point again of minimum of intensity. But what is this O point? O point is the central maximum, condition for central maxima of intensity. ठीक आहे, म्हणजे जे रेज डिफ्रॅक्ट होत नाहीत, डेफिएट होत नाहीत, त्यांना जर आपण ह्या लेन्समधून पास केलं तर स्क्रीनवरती आपल्याला इंटेन्सिटी डिस्ट्रीब्युशन पॅटर्न असा दिसतो. ओके, where to keep this screen? This screen has to be kept at the distance of focal length of this particular lens. ह्या लेन्सची जी फोकल लेंथ असेल त्या फोकल लेंथच्या डिस्टन्सवरती आपल्याला स्क्रीन प्लेस करायची कंपल्सरी, तरच आपल्याला हा इंटेन्सिटी डिस्ट्रीब्युशन कर्व असा मिळतो. Okay, then what is the condition for minimum of intensity? At this point, you will observe here minimum of intensity is observed. This one is first secondary maximum. This one is second minimum. This is second secondary maximum. This is third minimum. Okay, this is central maximum. Again, at this location means on both the sides of central maxima, you will get alternate minimum of intensity. In between two minimum of intensity, you will find there is a position that is called secondary maximum. Okay, so those rays which have not been deviated, जे रेज रळ जातात ते डिफ्रॅक्ट होत नाहीत, अँगल ऑफ डिफ्रॅक्शन थीटा, हे जे रेज डिफ्रॅक्ट होतात थीटा इतक्या अँगलमधून, ते आणि तेच अशा पद्धतीने ह्या ठिकाणी सुपरइम्पोज होत आहेत आणि आपल्याला सेकंडरी आणि मिनिमम, सेकंडरी प्रिन्सिपल, सेकंडरी मॅक्सिमा आणि मिनिमम ऑफ इंटेन्सिटी असे मिळतात ह्या ठिकाणी. ठीक आहे, so this is the basic concept of Fraunhofer's diffraction that you have studied. Now let us talk about few examples. So let us see the first formula, that is what in case of Young's double slit experiment, fringe width beta equals to d lambda upon d. You have to remember, you have to recall yourself. What is D? What is this D? This D is separation between two slits in Young's double slit experiment. D is the separation in between screen and source. Lambda, wavelength of the incident light. And this beta is the fringe width. Fringe width is simply distance in between two successive fringes. Okay. Then angular width, theta equals to theta equals to for theta equals to 2 lambda upon E. The next one, linear width. Linear width equals to beta equals to 2d lambda upon t. Okay. What is A? A is A can be replaced by D. Hmm? A is the separation in between two slits. D is also the separation in between two slits. मैं काही ठिकाणी ए वापरतो, काही ठिकाणी बी वापरतात, काही ठिकाणी ई वापरतात. ठीक आहे. So depends on that. You will find the uh, notations will be different in same example. You have to remember. ठीक है. Next, in diffraction experiment from a single slit, the angular width of the central maxima does not depends upon in diffraction experiment from a single slit. The angular width. What is angular width? Angular widthचा फॉर्म्युला हा बघितला आपण. Theta equals to 2 lambda upon d. So it depends on ratio of wavelength and slit width, wavelength of light used, width of the slit. हे सगळं आहे तिथे. This width of the slit. This is wavelength of light. Okay, then it is independent on distance of the slit from the screen. म्हणजे इथे कॅपिटल डी कुठेच आला नाही आहे आणि म्हणून आपण ते उत्तर लिहित असताना असं म्हणतोय in diffraction experiment from a single slit, the angular width of the central maxima does not depends upon. आता इथे अँग्युलर वेटचा कॉन्सेप्ट जर म्हणायचं असेल तर दिस इज लोकेशन. ह्या लोकेशनचा म्हणजे इथून इथंपर्यंतचं डिस्टन्स, इथून इथंपर्यंतचं डिस्टन्स त्याला म्हणतात लिनियर वेट. But in terms of angular width, this is theta. Okay, this is theta. So at this location, we should have to consider the condition for minima of intensity. And what is that? That condition is given by sine theta equals to n lambda. Okay, they are asking to calculate here. इथे आपल्याला काय कॅल्क्युलेट करायचंय, सेंट्रल मॅक्सिमा पासूनचा अँग्युलर वेट फाइंड करायची. हा सेंट्रल मॅक्सिमा आहे. तिथून इथंपर्यंतचा अँग्युलर अँग्युलर वेट ही करायची. म्हणजे आपल्याला थीटा द्यायचा आहे. ठीक आहे. आता हा थीटा घेत असताना समोरची बाजू आणि ही ऍडजस्टंट विथ रेफरन्स टू दिस थीटा. This theta equals to opposite side upon adjacent side. So it will be treated as tan theta. But if theta is very small, then we can treat that theta, sin theta equals to theta and tan theta equals to theta. And as per the condition we have obtained, condition for minimum of intensity at point P is given by E sin theta equals to n lambda. What is E? E is the slit width. त्यालाच आपण डी पण म्हणतोय, त्यालाच आपण ए पण म्हणतोय. ठीक आहे. म्हणजे कंडिशन काय होते, ई साइन थीटा इक्वल्स टू एन लॅम्बडा. बट हिअर एन इक्वल्स टू 1 फर्स्ट मिनिमम आहे. ओके, सो द सेम कंडिशन वी कॅन राईट ॲज साइन थीटा इक्वल्स टू n इक्वल्स टू 1 लॅम्बडा अपॉन डी. किंवा हेच एक्सप्रेशन साइन थीटा इक्वल्स टू lambda upon a, means if theta is very small, sin theta is considered as theta, and therefore angular width equals to lambda upon a. That's written. Okay, so it is independent on the separation in between slit to the screen. Okay. Next, so what is the answer? Answer is this one first. Then second. Second, in Young's double slit experiment, green light is incident on two slits. The interference pattern is observed on a screen. Which one of the following changes would cause the observed fringes to be more closely spaced? मगाशी मी तुम्हाला सांगितलं ब्लू लाईट, ग्रीन लाईट, रेड लाईट याच्यानुसार जो काही जे काही इंटरफिरन्स फ्रिंजेस मधलं डिस्टन्स असतं ते कमी किंवा जास्त होत असतं बिकॉज ऑफ दिस फॉर्म्युला विच इज दॅट फॉर्म्युला सेपरेशन इन बिटवीन टू सक्सेसिव्ह फ्रिंजेस बीटा इक्वल्स टू डी लॅम्बडा अपॉन डी. ठीक आहे. यंग्स डबल स्लिट एक्सपेरिमेंट. ग्रीन लाईट इज इन्सिडेंट ऑन द टू स्लिट्स. सुरुवातीला आपण ग्रीन लाईट वापरली. ठीक आहे. ग्रीन लाईट की ज्याची वेव्हलेंथ किती असते अप्रॉक्सिमेटली लॅम्बडा फॉर जी इज 5500 Armstrong unit. 5500 Armstrong unit. The interference pattern is observed on a screen. विच वन ऑफ द फॉलोइंग चेंजेस म्हणजे ग्रीन लाईट वापरली जी ज्याची वेव्हलेंथ 5500 Armstrong युनिट होती अशी वेव्हलेंथ जेव्हा आपण वापरली आपल्याला काही इंटरफेरन्स फ्रिंजेस दिसल्या. ठीक आहे. आणि त्या फ्रिंजेस मधलं जर डिस्टन्स आपल्याला कमी करायचं असेल ह्या फ्रिंजेस मधलं डिस्टन्स जे काही मिळालं ते जर कमी करायचं असेल तर याच्यापैकी आपण काय चेंज करू शकतो असं त्यांचं म्हणणं आहे. ठीक आहे. आपण सेम सेटअप असेल तर हा डी आणि हा डी हे दोन्ही काय असणार तर कॉन्स्टंट असणार. ठीक आहे. सेम सेटअपसाठी फक्त आपण इथे चेंज केला लॅम्बडा म्हणजे ग्रीन कलरच्या ऐवजी जर आपण ब्लू लाईट वापरला तर ब्लू लाईटची वेव्हलेंथ ब्लू लाईट ही अप्रॉक्सिमेटली 4000 म्हणजे व्हायलेट कलर किंवा ब्लू लाईटला तर साधारण 5000 पर्यंत जाईल. ठीक आहे. व्हायलेटची 4400 Armstrong युनिट 24800 त्यातलीच ही एक ब्लू लाईन. ठीक आहे. सो ब्लू कलरची लाईन ह्याची वेव्हलेंथ ही शॉर्टर आहे. वेव्हलेंथ शॉर्टर असेल तर डायरेक्टली फ्रिंज स्पेसिंग जे असतं ते कमी होणार. ओके. मीन्स इफ वी आर युझिंग the light having smaller wavelength as compared to green light, smaller wavelength as compared to green light, then obviously spacing in between two successive fringes decreases. Okay, so that's the answer using blue light instead of green light. That is the answer. Moving the screen away from the slits not much beneficial. Using red light instead of green light. ग्रीन आता रेड लाईटची वेव्हलेंथ जर आपण रेड लाईट वापरला तर काय होतं रेड लाईटची वेव्हलेंथ ही अप्रॉक्सिमेटली 6500 Armstrong unit. 6500 Armstrong unit. Okay, which is far much greater as compared to green light. म्हणजे ही जर वेव्हलेंथ पण इन्क्रीज केली तर ऑब्विसली बीटाच्या व्हॅल्यूवरती त्याचा इफेक्ट हा त्यांच्यामधलं डिस्टन्स इन्क्रीज करण्यासाठी होणार. आपल्याला डिक्रीज करायचं आहे डिस्टन्स इन बिटवीन टू सक्सेसिव्ह फ्रिंजेस. वी नीड टू डिक्रीज हिअर. सो लॅम्बडा शुड बी डिक्रीज. लॅम्बडा शुड बी डिक्रीज मीन्स instead of using red light we should use blue light. ठीक आहे. ओके. सो दिस द आन्सर. Next, the light wave of wavelength lambda is incident on a slit of width W. Okay, lambda wavelength of the incident light, slit width is D. The resulting diffraction pattern is observed on a screen at a distance of D. Okay, fine. if linear width of the principal maxima is equal to the width of the slit. Linear width means what? Obviously, beta equals to d. Linear width of the principal maxima is equal to width of the slit. Then the distance d. Then how it affects on distance d. Okay, that's the question. What is lambda? Wavelength. What is E? Slit width. What is beta? Beta is the separation in between two successive fringes. That is also called as linear width. Okay? And if this linear width equals to separation in between two slits or the width of the slit, then how it affects on T. What is the formula? If you are remembering, linear width beta equals to 2d lambda 2d lambda upon d. Therefore, therefore, d equals to beta into d upon 2 lambda. Okay. Here, what is given? Beta equals to d. That is the condition given. Beta equals to d. Okay. So it substitute that. So how it affects on d equals to beta is substituted by d into d upon 2 lambda. That is simply d square upon 2 lambda. Okay. Option आहे का बघा? That is simply d square upon 2 lambda. That is the value of d. Okay. So this is the correct answer. Okay. Lambda is given, speed is given. Then linear width beta equals to d, that is given, that we have used. The next one, in biprism experiment, the distance between source and eyepiece is 1.2 meter. Source and eyepiece, that means d. Source to the screen or source to the eyepiece की ज्याच्यामधून आपण इंटरफेरन्स फेनॉमिना आहे तो बघतोय. D equals to 1.2 meter. The distance between two virtual sources, that is small d equals to 0.84 mm. 0.84 mm equals to 0.84 into 10 raised to minus 3 meter. Fine. Next, wavelength of light used. If eyepiece is to be moved transversely to a distance of 2.799 for shift of 30 fringes. म्हणजे इथे त्यांनी फ्रिंज विड्थ दिली आहे. फ्रिंज विड्थ डायरेक्टली नाही दिली, तर डिस्टन्स इन बिटवीन फर्स्ट फ्रिंज टू 30 फ्रिंज अशी दिली आहे. Distance in between first fringe to 30 fringe, but we require beta. Beta is what? Beta is simply distance in between two consecutive fringes. Distance in between two consecutive fringes. And for that, we first need to calculate beta by simply taking this as 2.799. हे distance कशामधलं आहे? तर हे distance 30 fringes मधलं आहे. Obviously, we need to convert it in terms of meter because it is given in centimeter. 2.799 into 10 raised to minus 2 upon 30. ठीक है? So equals to. So that you need to calculate. You may check it. The answer is 9.33 into 10 raised to minus 4 meter. Okay, so this is the value of beta. Next, this is the value of beta. Okay, wavelength of light used. We have to find wavelength. So we have to use the expression that beta equals to d lambda upon d. But frequently we use this relation. And as per that, we obtain lambda equals to beta into d upon beta into d अपॉन डी, बीटा इंटू डी अपॉन डी. ठीक है. We have beta, we have D, we have capital D. Just substitute those values. So beta is 9.33 into 10 raised to minus 4 into D, separation between two success, separation in between two slits, 0.84 into 10 raised to minus 3 upon D, D ची व्हॅल्यू किती आहे 1.2 meter. So finally, the answer you will be getting, that is simply 6533, 6532.5 something, 6533 Armstrong unit. Okay, so you please check this as the right answer. What is the relation between Armstrong unit and meter? You should remember 1 Armstrong unit equals to 10 raised to minus 10 meter. Okay, 1 Armstrong unit equals to 10 raised to minus 8 centimeter. Okay, ठीक है. So these two relations you should remember. Then you will find the job is very easy. ठीक है. So the answer is 6533 Armstrong unit. So this is the correct answer. Okay. Both is completed. Any doubt? Arina, hello? Okay. Next one. Fifth. In Young's double-slit experiment, fifth dark ring is formed opposite to one of the slit. If D is the distance between slits and the screen, हे कॉमन झालं D ची व्हॅल्यू. ठीक आहे. And D is the separation in between two slits. Then the wavelength of light used. आता इथे आपल्याला काय दिलंय तर फिफ्थ डार्क रिंग, यंग्स डबल स्लिट एक्सपेरिमेंट, फिफ्थ डार्क रिंग. सो वी हॅव डार्क रिंग आहे हे लक्षात ठेवा. डार्क रिंग असल्यामुळे आपण एन लॅम्डाची कंडिशन नाही वापरू शकत. तर आपण कुठली वापरू शकतो तर फिफ्थ रिंगसाठी डिस्टन्स फ्रॉम सेंट्रल मॅक्सिमा टू द फिफ्थ रिंग, दॅट इज एक्सन. Okay, distance from the central maxima to the fifth minimum, fifth dark condition equals to 2n minus 1 upon 2n minus 1 upon 2 into lambda. This is for dark band condition, and remaining parameters will be as it is into d upon d. ठीक आहे. आपण असं बघितलं बीटा इक्वल्स टू डी लॅम्बडा अपॉन डी. दिस इज फॉर कंडिशन फॉर ब्राईट बँड. इथे एनची व्हॅल्यू आपण पकडली, इथे एनची व्हॅल्यू 5 आहे. ठीक आहे. त्यामुळे इथे आपला पॅरामीटर कन्सिडर करावा लागणार आहे. पण ही जी फिफ्थ डार्क रिंग इज फ्रॉम अपोजिट टू वन ऑफ द स्लिट, opposite to one of the slit. So 2x5 is equal to D. Since fifth dark fringe is formed opposite to one of the slit, okay, and therefore 2 into x5, that is D, that we have to say here, and therefore 2 times दिस डिस्टन्स. ठीक आहे. म्हणजे इथे तुमचं सेंट्रल मॅक्सिमा असेल आणि इथे फर्स्ट मिनिमा, इथे सेकंड मिनिमा, इथे थर्ड मिनिमा, इथे फोर्थ मिनिमा, इथे फिफ्थ मिनिमा. ठीक आहे. आणि हे टोटल डिस्टन्स जे आहे, हे टोटल डिस्टन्स त्याला आपण इथे एक्सएन म्हटलंय, एक्सएन. ठीक आहे. सो इथे यंग्स डबल स्लिटमध्ये 2 स्लिट्स आहेत. इथे एक स्लिट आहे, इथे एक स्लिट आहे, आणि दोन्हीमधलं सेपरेशन जे आहे ते डी इतकं आहे. ठीक आहे. आणि याच्या बरोबर समोर हे 5 फ्रिंजेस आपल्याला ऑब्झर्व होतात, आणि म्हणून 2 times x5 or x5 is equal to d upon 2. ठीक है? And by using this formula, what you can write, rearranging terms, 2 times xn, 2 times xn, 2 times xn, हा डी इकडे घेतला, हा डी इकडे घेतला, 2 times xn into d, 2 times xn into d upon d equals to 2n minus 1 into lambda. ओके, आता इथे xn इक्वल्स टू डिवाइड x ऑफ फिफ्थ इक्वल्स टू डिवाइड 2. इथे n च्या ऐवजी 5 टाका. 2 into 5, 10, 10 minus 1, 9. That is 9 lambda. So as per the formula, we can write here lambda equals to 2x5 d upon d into 2 into 5 minus 1 that we have substituted. ठीक है? So 2x5 means d. 2x5 means d. D into d. Here it is written. 2x5 equals to d. D into d upon capital D into 10 minus 1. So it is coming as d square upon 9d. D square upon 9d. Okay? So as per this formula, we have calculated lambda in terms of small d and capital D. Okay? So lambda comes out to be d square upon 9d. We'll check that. So this is the correct answer. Okay. Next one. The phenomena of interference is based on, there are 4 options: conservation of momentum, quantum nature of light, conservation of energy, and conservation of charge. Okay. The phenomena of interference means what? It is simply light energy plus light energy from 2 different sources. Having said that, light energy plus light energy is either maxima or minima. That phenomena is called interference phenomena. That is very simple. Okay. Now, energy is going to redistribute due to the superposition theorem. Energy is going to be redistributed either in producing maximum of intensity or minimum of intensity. Okay, that means that intensity is directly related with the concept of energy, E upon T upon surface area. This is intensity. Intensity is going to be modified, and intensity of the light wave equals to energy transported per unit time per unit surface area. Energy transported per unit time per unit surface area. That is called intensity. So from this definition itself, you can say that there is a conversion of one form of energy into another form of energy. That is called conservation of energy. So interference phenomena is the based on conservation of energy. Energy is going to be redistributed in producing maximum of intensity or minimum of intensity. Okay, so that option is correct. The next one, 7th, 2 light waves. किती वेळ सर आहेत ना 20 मिनिटं. 2 light waves of intensities I1 and I2 having same frequency. Frequency same, wavelength same. ठीक है, pass through same medium at a time in the same direction and interfere. Okay, fine. The sum of minimum and maximum intensities is given by, what is the option? See, we know that when I maximum will be produced, I maximum will be produced when the two amplitudes, okay, two amplitudes are going to superimpose on each other in a constructive manner. Okay, we know that I is I intensity is directly proportional to modulus of A square. That is amplitude square is intensity. ठीक है amplitude square intensity A1 square plus A2 square A1 plus A2 square that is I maximum. What is I minimum? Minimum I केव्हा असेल जेव्हा A1 minus A2 A1 and A2 त्यांचे amplitude ही जेव्हा एकमेकांना कॅन्सल करायचा प्रयत्न करते तेव्हा त्या ठिकाणी मिनिमा येतो. सो A1 and A2 ब्रॅकेट स्क्वेअर. ठीक आहे. नेक्स्ट द सम ऑफ मिनिमम अँड मॅक्सिमम. आता या दोघांची सम घ्यायची. आय मॅक्सिमम आणि आय मिनिमम. सम ऑफ आय मॅक्सिमम अँड आय मिनिमम. That we can take I maximum plus I minimum equals to A1 plus A2 square plus A1 minus A2 square. ठीक है. Solve this. So equals to A1 square plus A2 square plus 2 A1 A2 plus A1 square plus A2 square minus 2 A1 A2. Fine. So it is coming as 2 A1 A2 cancels with this 2 A1 A2. So what is left here? A1 square plus A1 square plus A2 square plus A2 square. Okay? So that is equal to 2 into bracket A1 square plus A2 square. Fine. But here they are asking in terms of intensities. Intensity of first wave is I1 of amplitude capital A1. Intensity of second wave is A2, is I2 with amplitude of A2 of second wave. So that directly we can write as uh, I maximum plus minimum equals to 2 times I1 plus I2. Finish. Within one step, we are getting this answer. Nothing. So this is the correct answer. Okay. 2 times I1 plus I2. This question was asked for MHCT 2018. So simple. Next one. 8th. Two identical light waves having phase difference of phi propagate in same direction. When they superimpose, the intensity of resultant wave is proportional to. ओके. दोन वेव्स आहेत त्या एकमेकांना सुपरइम्पोज करतात त्यांच्यामध्ये काहीतरी फेज डिफरन्स आहे तर त्यांच्या इंटेन्सिटीमध्ये काय फरक पडेल असा क्वेश्चन आहे. रिझल्टंट इंटेन्सिटी आय आर इक्वल्स टू I1 plus I2. I1 plus I2. This formula you have studied while discussing with the theory. ठीक है. I1 plus I2 plus 2 square root of I1. Sorry. Square root of I1, I2 and cos phi. Cos phi. इथे हा फॉर्म्युला दाखवते तुम्हाला. See this formula. हा दिसतो का बघा? हा फॉर्म्युला. रिझल्टंट इंटेन्सिटी इज इक्वल टू, हाताने जातो हा फॉर्म्युला. I equals to I1 plus I2 plus 2 times square root of I1 I2 cos phi. ठीक है. If I1 equals to I2 equals to I0 because having same frequency. Okay. Okay. So for two identical waves, I1 equals to I2 equals to I0, or directly you can write it as I. So I resultant intensity equals to 4 times I cos square pi by 2, cos square pi by 2. ठीक है. So IR resultant intensity is directly proportional to cos square pi by 2. ठीक आहे. सो तुम्ही इथे फक्त काय सबस्टिट्यूट करायचे, I1 इक्वल्स टू I2 इक्वल्स टू I टाका. हं? तर इथे तुम्हाला मॉडिफिकेशन होणार, I1 प्लस I2 प्लस 2 I1 I2 मॉडिफिकेशन होणार आणि ह्या फॉर्ममध्ये आपण लिहिणार I1 इक्वल्स टू I2 इक्वल्स टू I, म्हणजे हा फॉर्म्युला. सो इट इज द आन्सर when they superimpose. म्हणजे अशा दोन वेव्स की ज्यांच्यामध्ये फेज डिफरन्स आहे, तर त्या जेव्हा एकमेकांना सुपरिम्पोज होत आहेत तेव्हा त्यांच्या इंटेन्सिटीवरती त्याचा काय इफेक्ट होतो. ओके. आपण असं म्हणतो की डिपेंड्स ऑन द फेज डिफरन्स वेदर दे आर प्रोड्युसिंग द मॅक्सिमम ऑफ इंटेन्सिटी और मिनिमम इंटेन्सिटी विल ऑकर. तर तो तो रिलेशन इथे आपण देतो. दिस आन्सर बी. B equals to B is the right answer. That's cos square pi by 2. Next one, ninth example. In Young's double slit experiment, in an interference pattern, second minimum is observed. Second minimum is observed exactly in front of one slit. The distance between two coherent sources is small t. Okay, and the distance between source and screen is capital D. Fine. The wavelength of light source is, how it depends on d and small d, that you have to find. In Young's double slit experiment, the Young's double slit experiment, y, that is the displacement of a beam of light, y equals to, this is a dark ring, okay. For dark ring, we are having the expression 2n minus 1. आता हे कन्फ्युजन करू नका की इथे तुम्ही बेटा पण लिहिताय, इथे एक्स पण लिहिताय, इथे वाय पण लिहिताय. ओके. तर इथे ज्याप्रमाणे डेटा दिलेला असतो त्याप्रमाणे आपल्याला हे हे नोटेशन्स चेंज करावे लागतात. ठीक आहे. बेटा आहे फ्रिंज फिल्ड, एक्स आहे डिस्टन्स फ्रॉम सेंट्रल मॅक्सिमम टू द रिक्वायर्ड मिनिमम, वाय इज ऑल्सो लिनियर फिल्ड. ठीक आहे. हे यांचा मिनिंग सेम आहे. Meaning same separation of that particular location from the central maximum range distance system. ठीक है. So 2n minus 1 into lambda by 2 into d upon small d. Okay. Next, here y equals to d by 2, half equal distance, and that happens for n equals to 2. इथे म्हटलंय second minimum. Which minimum? Second. Means for n equals to 2, in Young's double slit experiment, in an interference pattern, second minima is observed exactly in front of one slit. Separation in between two slits is d. Separation in between two slits is small d. आणि त्याच्याबरोबर हाफ इतक्या डिस्टन्सवरती ही तुम्हाला फ्रिंज विड्थ मिळते, y इक्वल्स टू d अपॉन t फॉर n इक्वल्स टू 2. थोडंसं समजून घेण्याचं बाकी आहे. तर ते इथे अप्लाय करता येत आहे. So what is the wavelength of light used? So just substitute in the formula. Just rearrange these terms. So it will be 2y small d, 2y small d upon 2n minus 1 into capital P equals to lambda. चेक करा. 2y बरोबर आहे इंटू डी इकडे येता अपॉन 2n-1 into capital D equals to lambda. And that lambda we have to find here. What is y value? Y equals to d by 2. N equals to 2. ठीक है? Substitute those values. So 2 into d upon 2 into d upon 2 into 2 minus 1 into d capital P equals to lambda. So ultimately 2 will get cancelled. D square upon 4 minus 1, that is 3 into D. So that is equal to D square upon 3D is the value of corresponding lambda. Which option is correct here? Third option, D square upon 3D. Okay. Next, 10th one. Interference fringes are produced on a screen by using two light sources of intensities I and 9I. ठीक है एकाची इंटेन्सिटी I आहे दुसऱ्याची इंटेन्सिटी 9I आहे. The phase difference between the beams is pi by 2 at point P and pi at point Q on the screen. ठीक है. So there are 2 points की एका लोकेशनला P पॉइंटला at point P phi equals to pi by 2. Phi equals to pi by 2. Okay. And at point Q, phi equals to काय बघायचे pi. Phi equals to 2. What the expression you are having? Write the two expressions, one for IP, P point, and another for IQ. IP equals to I1 plus I2 plus 2 into square root of I1, I2 cos phi, phi became pi by 2, phi equals to pi by 2. Okay. So I1 is I2 is 9I plus 2 plus 2 square root of cos of pi by 2 0. So this term will become as 0. Cos of pi by 2 0. So IPE we are getting expression IP equals to I plus 9I cos 5 cos pi by 2 I1 I2 into 0. Okay, this term is 0 because cos of pi by 2 is equal to 0. So IP equals to किती येणार सांगा 9 plus 1 that is 10I. Call this as first expression. Now 10I. Similarly, IQ I at Q I1 plus I2 plus 2 times square root of I1, I2, cos pi. Cos pi is cos pi. ची व्हॅल्यू किती आहे पाय. कॉस पाय इज -1. ठीक आहे. I1 ची व्हॅल्यू आय, I2 ची व्हॅल्यू 9i प्लस 2. आता इथे कॉस पाय -1 आहे ना, त्यामुळे इथला हा पॅरामीटर मायनस होतो. 2 इंटू स्क्वेअर रूट ऑफ I इंटू 9i मीन्स 9i स्क्वेअर. ठीक आहे. सो इक्वल्स टू 10i मायनस 2 स्क्वेअर रूट मधून 9 आउटसाइडला घेतले, आय स्क्वेअरला पण आउटसाइडला घेतलं. सो इट विल बी सिम्पली 3i. It will be simply 3i. So 10i minus 6i. 10i minus 6i, that is 4i. That is the value of intensity at Q point. Okay? So that is equation number 2. Intensity at Q point is 4i. Intensity at P point is 10i. Okay? Then they are asking difference between the resultant intensities at point P and Q. So subtracting or taking the difference in between first and second. So IP minus IQ equals to 10i minus 4i equals to 10 minus 4 6i. आहे का बघा. ऑप्शन आहे का बघा. IP minus IQ. IP minus IQ equals to 6i. So this is the correct option. 6i. Okay. Next one. Okay. Two coherent sources P and Q produces interference at point A on the screen where there is a dark band which is formed between a fourth bright band and fifth bright band. Okay. Wavelength of light used is 6000. The path difference between PA and QA is. Here, what is given that we will write first. P and Q produces interference at point A on the screen. Okay. There are two sources, P and Q, that are supposed to interfere to superimpose on each other. At A point, they are superimposing. Where there is dark band, condition of dark band, which is formed between fourth bright band, n equals to 4, fourth bright band. Okay. After fourth band, that dark band is coming. Fourth bright band, त्याच्यानंतर म्हणजे मॅक्सिमा असतो परत मिनिमा असतो. म्हणजे फोर्थ ब्राईट आणि फिफ्थ ब्राईट ह्याच्यामध्ये तुमचा मिनिमा आहे. ओके. वेवलेंथ ऑफ लाईट युज्ड लॅम्बडा इक्वल्स टू 6000 into 10 raised to minus 10 meter. ठीक आहे. The path difference between PA and QA. A पॉइंटला ते सुपरइम्पोज होत आहेत. स्टार्ट फ्रॉम P and Q. म्हणजे PA हा फर्स्ट रे असणार आणि QA हा सेकंड रे असणार. ठीक आहे. मग ह्याच्यामधला पाथ डिफरन्स हा किती आहे असं ते विचारतात. द डिफरन्स इन द पाथ ट्रॅव्हल्ड बाय टू रेज. विच आर द टू रेज? First ray is PA, second ray is QA. Okay, so see, we will assume here path difference equals to delta x. हा path difference आहे असं आपण assume करूया. मग आता आपल्याला एक रिलेशन माहिती आहे. ही जर अशी वेव्ह असेल, ही अशी वेव्ह, तर वेव्ह इथून स्टार्ट होते आणि इथे संपते. Okay, and this total phase is simply 2 pi. Wave starts from 0 ends at phase difference of 2 pi. At this location, there is a pi. इथे pi by 2, इथे 3 pi. म्हणजे एक वेव्ह कंप्लीट झाली, पार्टिकलनी एक ऑसिलेशन कंप्लीट केलं आणि त्यालाच आपण म्हणतो लॅम्बडा. सो 2π करस्पॉन्ड्स टू लॅम्बडा. 2π का फेज डिफरन्स असेल तर वेव्हलेंथ किती असते, लॅम्बडा इतकी असते. 2π इज द फेज डिफरन्स आणि लॅम्बडा इज द पाथ डिफरन्स. आपण आत्ता असं म्हणतोय की फेज डिफरन्स इज लॅम्बडा, सॉरी फेज डिफरन्स हा डेल्टा म्हणतोय. इथे पाथ डिफरन्स हा डेल्टा एक्स म्हटलं, पण फेज डिफरन्स माहित नाहीये. फेज डिफरन्स इज डेल्टा. हा फेज डिफरन्स डेल्टा घेत असताना आपल्याला पाथ डिफरन्स किती येईल तर ते आपल्याला कॅल्क्युलेट करावं लागेल. फेज डिफरन्स हा 2π असताना पाथ डिफरन्स हा लॅम्बडा आहे, तर फेज डिफरन्स डेल्टा असताना पाथ डिफरन्स हा किती असणार, त्याला आपण डेल्टा एक्स म्हटलं. ओके, सो 2π corresponds to lambda, so delta corresponds to delta x. This delta, that is phase difference. So delta x into 2π equals to delta into lambda. Okay, that means delta x equals to delta upon 2π into lambda. Okay, that is delta x, that is the path difference. This delta is the phase difference. Okay, and 2π as it is into lambda. Now next, here n equals to 4. आता हे रिलेशन तुम्हाला लक्षात ठेवायचं आहे. डेल्टा x equals to phase difference upon 2π into lambda. Here n equals to 4. n equals to 4. ठीक आहे. Then delta for dark ring. Delta is the phase difference. And how it can be obtained? Simply by taking 2n plus 1 into pi. Delta. So the value of delta as per the given data is 8 plus 1 into pi. That is delta equals to 9π. Okay. And substitute this value of delta in this equation. So we can obtain here delta x equals to delta ह्या लोकेशनला काय आहे, डार्क रिंग होती, तो आपण 2n plus 1 घेतला. डेल्टा एक्स इक्वल्स टू 9π, सॉरी येस 9π into lambda upon 2π. तर जे इथे आन्सर पहिला पॉईंट आन्सर होतो. सो 9/2 into 6000 किती दिली आहे, 6000 Armstrong unit, that is 10 raised to minus 10. Delta x equals to 9/2 into 6000 into 10 raised to minus 10. So after calculation, you will find this as metric. Okay, so the answer is 2.7 into 10 raised to minus 4. You please check it. सेंटीमीटर. इथे -8 घेतलं असेल तर ते सेंटीमीटरमध्ये, -2 असेल तर मीटरमध्ये. ठीक आहे. सो दिस द ऑप्शन. नियर अबाउट आपण अप्रॉक्सिमेटली करू शकतो. 2 3s are 6, 9 3s are 27. Okay, so the answer is coming as 2.7 into 10 raised to minus 4. एक्झाम्पल समजणं हे खूप जास्त महत्त्वाचं आहे, आणि मग छोटे मोठे फॉर्म्युले असतात ते थोडे अप्लाय करावे लागतात, तरच आपलं आन्सर हे करेक्ट येतं. ठीक आहे. सो सिम्पली रिलॅक्स द फॉर्म्युलेज, ट्राय टू अंडरस्टँड द एक्झाम्पल, राईट द गिव्हन डेटा प्रॉपरली and solve the examples. Okay, so we'll stop here.